Hello, and welcome to Secure Talk, a podcast where we explore the critical world of information security innovation and compliance. I'm your host, Justin Beals, founder and CEO of StrikeGraph. Together with our expert guests, we'll provide you tools and tips to help your business thrive in the rapidly evolving cybersecurity environment. Hello, everyone, and welcome to Secure Talk. I'm your host, Justin Beals. In the 1990s, a group of hackers worked late into the night in a converted hat factory in Boston, fueled by techno music and an insatiable curiosity about how computer systems really worked. They called themselves Loft, and their approach was simple: smarter beats bigger. Rather than throwing more resources at security problems, they used deep technical knowledge and creative thinking to expose vulnerabilities that massive corporations had missed. One of those researchers, Wysopal, would later testify before Congress that a small group of dedicated hackers could take down the entire internet in 30 minutes. The message was clear. In cybersecurity, intelligence and precision matter more than scale and resources. Fast forward to today, and we're facing a remarkably similar moment. The AI industry has convinced us that bigger is always better. More data, larger models, more parameters. But what if they're solving the wrong problem entirely? Chris and his team at Veracode just completed one of the most comprehensive studies of AI-generated code security ever conducted. They tested 100 different language models across 80 different coding scenarios, and the results reveal something the AI industry doesn't want to admit. These systems create vulnerabilities 45% of the time, exactly matching human error rates. After 2 years of development and billions of dollars in investment, AI hasn't made code more secure. It's simply learned to replicate the same mistakes humans make, but at exponentially faster speeds. Think about the mathematics of this problem. If AI accelerates code development by 3x, which is conservative given current capabilities, we're not just getting 3 times more code. We're getting 3 times more vulnerabilities. A development team that previously introduced 100 security flaws per quarter could now be introducing 300. The attack surface doesn't just grow linearly, it explodes. What makes this even more dangerous is that many organizations are reducing their security testing capacity. At the exact moment, they're amplifying their vulnerability creation rate. They're betting that AI will make code inherently more secure, but the data shows the opposite is true. The root problem is training data quality. These models learn primarily from Reddit and open source repositories, essentially crowdsourced code with no security review. It's like teaching someone to drive by showing them footage of every car accident ever recorded. The models have gotten remarkably better at writing syntactically correct code, but they've absorbed decades of security anti-patterns without any filter. But there is hope in Chris's findings. The same study revealed that smaller, specialized models focused on specific security tasks dramatically outperform general-purpose AI. Veracode's code fixing tool, trained on curated datasets of known secure code, succeeds precisely because it does one thing well, rather than trying to do everything. This mirrors the Loft philosophy perfectly. Sometimes the smartest approach isn't building the biggest system, it's building the right system. And as we stand at another inflection point in computing history, the lessons from that Boston hat factory seem more relevant than ever. And Chris is the chief security evangelist at Veracode, responsible for enhancing the company's industry presence, advocating robust security practices, and fostering customer and peer relationships. Prior to co-founding Veracode in 2006, Chris was vice president of research and development at security consultancy At Stake, which was acquired by Symantec. In the 1990s, Chris was one of the original vulnerability researchers at the Loft, a hacker think tank where he is one of the first to publicize the risks of insecure software. He has testified to the U.S. Congress on the subjects of government security and how vulnerabilities are discovered in software. Chris is a highly influential and sought-after voice in the software security industry. He is the author of The Art of Software Security Testing and was instrumental in developing industry guidelines for responsible disclosure of software vulnerabilities. MIT Technology Review wrote in 2019 that Chris has worked for decades to demand secure technologies from influential tech companies. Please join me today in welcoming Chris to the Secure Talk podcast. Thanks, everyone, for joining us on Secure Talk. And thanks, Chris Wysopal, for joining us today on Secure Talk. We really appreciate you lending your expertise to our audience.
Hi, Justin. Thank you for having me.
Yeah, excellent. So, of course, I love doing the research work that we do with our guests. And really something hit me about your background that I just popular culture-wise had to learn about. It was absolutely intriguing. So you were one of the first members of the Loft hacking group that started out in like a Boston hat factory. I think this was in the 90s. Is that right, Chris? It was a while ago.
Yes. And I think we pronounce it Loft.
Thank you.
Because it was more as a play on, an industrial loft space, right? In a factory building was where we were. And yes, it did actually start off in a light manufacturing building that some of the Loft members' wives had actually started a hat making business in and realized that they had too much space. And so they gave half of the space over to their husbands, who proceeded to invite more people in. And then the hat making business went out of business and we just got the whole space. So we have to thank Marianne and Alicia for finding us the space.
I just think it's such a moment in time, and of course I love remembering it because I was getting my first experiences on computers and modems and what it meant to be able to dial up other systems, and it was really a very creative time. I thought, like, we were learning about these tools and what was possible with them, and so. I'm curious, what was the mixtape? What was the soundtrack that was going on in the Loft as you guys were late at night, plugging away on some of these areas?
Well, I have to mention the movie Hackers, because I think the soundtrack for the movie Hackers, like Orbital, Left Field, The Prodigy, was the kind of music that we actually listened to. So it isn't like we followed what the hackers said. I think the movie did their research, and people who were in the hacker scene were into sort of the techno music genre at the time. I mean, it makes sense, right? It was actually digital at the time, right? I see you have some synths back there, so you understand. Synth started out in the analog world, and then I guess in the late 80s became digital. But obviously. We like that kind of music. But I do have to mention one other band that we kind of had the tape and it was just sort of on repeat all the time, was a band called Soul Coughing. I don't know if you've ever heard of them.
Definitely.
It was sort of like, I don't know, 93, 94, their first album came out, and it sort of had this mix of jazz with, sort of rock, and it was some cool stuff.
I was joking with a friend the other day. I was like, "Oh, you missed the whole acid jazz era."
Yeah. No, totally. I think Soul Coughing was in there just with the kind of the crazy lyrics they had, and I actually saw them live at CBGB's one year, which is amazing. And the bass player plays a stand-up bass like you would expect in a jazz band instead of a rock band, right? And gives a whole different flavor to live performance.
How wonderful. It's certainly really, I loved hearing about that. And I think a shared experience culturally for those that working in the computer science space, obviously about our vintage, where we were playing with those tools and listening to those music and finding a lot of creative opportunity. Now, you're at Veracode today, I believe. Yes, is that right? Yeah.
Still here after 19 years.
That's amazing. Yeah. And I want to jump ahead a little bit because there's a ton of history between Loft and Veracode today, but Veracode's been doing some really interesting work in an area that I think I'm very curious about. You guys recently published a report, the 2025 Gen AI Code Security Report. Maybe just give us a high level of the topic area of the report.
Sure. So we have thousands of customers, and we talk to them, and we realize that almost all of them are using generative AI to build software, and it's probably the most prevalent use of generative AI. If you look at just the numbers of people doing it, millions of developers are out there using tools like Copilot, using tools like Claude Code, just using ChatGPT. And we wanted to get an understanding of how is this impacting application security? Because, our job as an application risk management company is to help people find vulnerabilities in their code and fix them. And so we wanted to see how this Gen AI coding was impacting software development. And so we devised a test where we came up with 80 different code completion examples. And a code completion example is like you have some code, right? You're not saying write a program from scratch. That's kind of the vibe coding concept, where you're just maybe not a professional developer and you're writing a whole program and the AI is doing it for you. Code completion is when you're a developer asked to do a particular task and you just kind of, it's some grunt work, or it's something you can't remember how to do. And you just say, I need a SQL query here. I need a database query that will, find all the rows with this value. And you just do it in plain language, and it writes the code for you and inserts it in there. And so we knew this kind of code completion activity was happening in all of our customers, and perhaps on every single project that they had, every single app they were building. But definitely way into the double digits of developers are using this. And I've heard upwards of 40% of developers are using it. And so we devised 80 code completion tasks where there's a piece of code, and then there's some comments in there that says, Gen AI, please complete what this comment is asking you to do. And we took these 80 test cases and we ran it through 100 different LLMs. And over the last, I don't think it's quite 2 years, but maybe 21 months. No, I think it went back 2 years. About 2 years, we went back in time. And so some of these are the same version. It might be GPT-3, GPT-4, GPT 4.5. But, there's a lot of different LLMs out there, especially in this space where people are just building ones just for coding. And we looked at the findings and said, things like, are all LLMs created equal? Are they improving over time? How often do they create a vulnerability when they're asked to complete a coding task? And the high level result we got when we sort of looked at all the LLMs and we looked at all the different coding tasks we asked it was about 45% of the time when we asked it to write code, it created a vulnerability. And we actually find that that's very similar to a human level of vulnerability creation. Just because writing secure code is actually pretty hard. There's hundreds of ways you can make a mistake that will cause a vulnerability that some attacker could take advantage of if they test for it and they find it and they write an exploit. So that was sort of the high level finding we had, which I think is a wake up call to everybody that just because you're using these Gen AI tools to write code faster, and maybe you might even think it's better from a functional standpoint, it's no better from a security standpoint. And that was really the message we wanted to get out there is because I think there's an assumption that these LLMs are great at everything. Yeah. And writing secure code is one that they're definitely not at.
First off, I mean, there's a couple of things that I really love about this. One is kind of the rigor with which you're testing LLMs, which are largely what we might consider like a qualitative outcome instead of a quantitative prediction. I understand that underlying there, what it decides to suggest is rolling up through a probabilistic or a quantitative amount.
Yeah. So we tested afterwards with our static analysis tool. So that was sort of our oracle, right? So a known quantity. Now, I'm not saying it didn't create a vulnerability that, we couldn't find.
Yeah.
But that's what this is a lot of this is for our customers to get an understanding, and they're using our static analysis testing to test their code. So they understand the vulnerability density they have. And this was saying now you can compare to what you would be getting if you were using generative AI, which they probably already are.
Well, and too often we look at these things like, oh, you can't really test it. But this is where I think I get frustrated from a computer scientist perspective in our work in AI tools, is that we don't do enough testing around the accuracy or precision of some of these tools that we develop. And I'm just really glad to see, the way you guys designed the study, to run these types of comparisons. I mean, the other thing that's kind of shocking is I think that a lot of us would have assumed that the amount of, failure rate, from that 38 to 45% would be dramatically more than what a human would get. But
right.
I mean, one of the things I read into is that all that incoming data that we train the LLMs on is generating the same error rates.
Exactly. I mean, that's one of the things that, you start to look at, like I looked the other day, like what are LLMs mostly trained on? Number one is Reddit. Number two is Wikipedia. Now, Wikipedia is a crowdsourced encyclopedia. But the challenge with Reddit is it is crowdsourced, but it doesn't have the rigorous approval process and things that Wikipedia has. And I think there was like 50% more of the training data came from Reddit than LLMs. And of course, it's coming from all of the sources like Twitter and Facebook and other things too. But it was interesting that Reddit was number one. Now, if the parallel with training on writing code is open source, right? Yeah. There are some companies like Facebook, which has their own code bases of all their products. And of course, Google has the code bases of their products. But, a company like, OpenAI, they don't have a big suite of products like those companies do. So, and they're all training on open source, right? There's just millions and millions of open source applications that are out there in GitHub and other open source repos. And, there's no quality control there. Anyone can write code and put it up there, right? No one is telling someone you need to pass this quality test. It's just out there. I don't know if they were weighting projects that are more popular, like an Nginx web server or a particular popular package, right? Or the Linux kernel, like those are more highly vetted, right? Than, Joe's website generator. There's no scrutiny of that data. So it's just code. Now, one thing that we did find that was really even a more interesting finding, I think, than the level of vulnerabilities was we found that over time, the LLMs have gotten better at writing syntactically correct code. If you go back 2 years ago, only about 50% of the code completion tasks actually wrote syntactically correct code, right? Which is pretty bad, right? You're like, wait, it couldn't even learn to write it syntactically correct. And then if you follow that over the next year, 18 months to 2 years, we saw a dramatic improvement in syntactically correct code, just to the point that 6 months ago, it hit 95% of the code completions were syntactically correct.
Wow.
The LLMs from 6 months ago. And that kind of plateaued at 95%. But we didn't see any kind of improvement on writing secure code. So my theory is they actually are building these projects before they consume them as training data. And they're seeing that the code is not just maybe a sample exercise that someone just wrote, that it's actually a functionally, syntactically correct program. It actually builds. And if you think about that, that's a way to get a data set that will write syntactically correct code. You have better data going in. So I think the same thing could happen with secure code. You'd have to only test, or you'd only train on code that has passed a certain security test and the vulnerabilities have been fixed. Or maybe just identified, and that becomes an anti-pattern. Mm-hmm. Don't write your SQL queries this way. So I think it's going to be possible for LLMs to get better at writing more secure code. It's just that it doesn't seem like we're even close to it because we've been flat for 2 years.
Yeah. I mean, I'm gonna crack open another buzzword space a little bit when we talk about it. We've been finding solutions though with this technology, and I think this is where we like the agentic style systems, because we can utilize a couple of models for their strengths in sequence or series, or to inform logical next steps, and they start to counterbalance each other in the decisions in some ways.
Yeah, so that's true. So people say, well, why can't you ask the LLM to write code, then ask the LLM to find the vulnerabilities in the code, and then ask the LLM to fix the code? Yeah. And my answer to that is we already have a technology that's better at finding vulnerabilities in code. It's called static analysis, right? Yes, we've been doing it for 20 years. We refined it, all these different languages and frameworks and all these different vulnerability classes. And today I can tell you it's better at finding vulnerabilities than an LLM is. So use that. Doesn't say LLMs won't get better at some point in time. Obviously, we're working on this technology and seeing if we can get it to be better, but we haven't found it to be better than the traditional deterministic algorithms that we have for doing static analysis security testing. But one thing that we did do is we built a product called Veracode Fix, which uses an LLM to fix code. And it turns out that LLMs are really good at fixing code if you point out where the problem is and you tell them what the problem is. Because then it doesn't have to think about finding it or classifying it. It just says, you say, there's a cross-site scripting error on this line of code. Make this secure, make it safe. And that's a huge productivity tool for developers, because developers have problems fixing code even when it's pointed out to them with the vulnerabilities. They don't know how to fix it. So training LLMs to fix code seems to be easier than training them to find vulnerabilities. But I have hope that that will improve. But I'm happy that we're fixing code better than, or at least we're able to fix code because we're creating all these new vulnerabilities.
Yeah. I mean, it is an interesting operations space, I think, when you think about these large language models in a way, because code, is maybe a smaller lexicon, like the vocabulary is smaller, but it still has a powerful combinatorial effect. And therefore,
absolutely.
Yeah,
it gets very complicated very fast when you think about 1 million lines of code. That is definitely one of the factors that makes it easier to fix than find, because fixing code is really localized. There's not a huge context window. It's probably just like maybe 10,000 tokens or something, which all LLMs can handle that. So it's because it's usually just in a class and a method. It's not that complicated. But finding a vulnerability could span hundreds of thousands of lines of code. So now we're potentially talking about millions of tokens. And even the largest models now are struggling with that. And nevertheless, the compute power that chugging through millions of tokens is compared to a few thousand tokens, right? It's thousands of times that. So I'm happy we can fix, and someday we'll get better at finding.
Yeah. Well, and I think to your point in this area is that there was a finding that 86 to 80% of the time the models failed, especially on cross-site scripting and log injection, because it is kind of an inner procedural data flow, right?
Absolutely. So I think I think this really mirrors the way that people write code, and that's why it failed. I think that, for one thing, things like SQL injection and cryptography, which it did better on, right? It only had a failure rate of in the 20-30% range, right? Yeah. Which is still bad, right? I don't want to bug every fifth prompt to create a vulnerability. We're still not happy with that, but it was much better than, say, cross-site scripting. And I think a lot of it had to do with the context being more understood. And also I think there's a lot of tutorials and blogs and literature out there about these very dangerous vulnerabilities like SQL injection. And there's also a lot of literature out there how to write crypto properly, right? It's like a big deal to do it right or wrong. Where cross-site scripting is one of these things where it's everywhere a web application outputs to an API or outputs to an HTTP request back to the user to render on their screen. It's like it's everywhere, right? Mm-hmm. It's all throughout the program. That's the whole UI. And like you say, there's a lot of interprocedural pieces between where untrusted data might get into the program and where it might be sent to the user and cause a cross-site scripting vulnerability. And developers don't code defensively, right? What happens is they say, well, if I know this is untrusted data, then hopefully I'll remember to do output encoding and protect the user from this untrusted data. But in the general case where they don't know, or maybe they think it's trusted data, hey, it's just coming out of my database, I think this came from a trusted source, they don't do it. And so that's the pattern that we see in code. And that's why cross-site scripting is so prevalent, right? So it's learned this pattern and it hasn't learned how to do it properly.
Yeah. Definitely on all my pen tests as a CTO or as an engineer, I always expected to get a couple cross-site scripting errors, that I had to look through. It is Absolutely. Very common. Yeah. And I think it does speak to kind of, that the developer starting to be more context aware of the entire platform and these tools helping them in the minutiae, in the minute. The other thing that I thought was really interesting is that not all languages were created equal from a LLM. Java is 72% failure rate. Yeah.
Yeah, that was an interesting one that, Java is, the oldest language there, created in the mid 90s. Now it's 30 years old and it was created to be a secure language, right? But yeah. Secure meant just don't have buffer overflows and memory corruption issues like compiled languages like C and C++ have. That's what they meant by secure. Eliminate memory corruption. Well, we know memory corruption is like it's a very important category. Don't get me wrong, but it's probably like 1/10 of the issues out there. And that's because we hadn't found all the other issues yet. Like things like SQL injection, cross-site scripting weren't discovered for like 3 or 4 years after Java as a language was created. So it didn't do anything to prevent them. So I think we had many, many years of bad Java code being written, maybe 10 years from 95 to 2005, till a lot of Java programmers started to say, hey, maybe I should do security testing. Maybe the language isn't protecting me from everything. And that's the thing with code is it's like, it's all still out there. Yeah. Right. Why would an LLM stop with the most recent version of something when it goes back for 20 years? And there's all kinds of other algorithms in there that, were useful for doing something, but then the program changed and they don't do that anymore, right? So a lot of and there's been academic papers actually on this saying that one of the reasons they think that the LLMs code so badly is they learned on a lot of old code. They didn't just cut off and say, I'm going to learn code from 2020 on, right? And we know the longer you go back, code gets more insecure because we learn of new vulnerability classes, and we learn how to do things better. Especially if you think about crypto, right? Crypto, like whole crypto algorithms have been deprecated. And you have to wonder, is the LLM learning from the comments that say, we're deprecating DES here and we're switching to triple DES? You would hope that it would learn that and never write anything at DES. But it's not totally clear that it's learned all the right things from old code.
Yeah. And we see, as we start to layer these kinds of features, I'm sure at Veracode y'all do too, utilizing neural networks or these types of data science work that's very modern, that it really continues to be a data in, data out issue. And if you craft the problem you're trying to solve to the data you need to collect to solve that problem to the right style of model or machine learning, that you can get a very powerful outcome. But if you just throw, a qualitative output from a random LLM at something, you get a very random outcome.
Exactly. This is one of the things we did with our Veracode Fix product. Is we used a trusted data set of known secure code, like because as a company that tests code, we have a lot of code samples. Yeah. And so we have a lot of known bad code, known good code, all reviewed by humans after being reviewed by the machine, and then using those to train what's bad, what's good, in order so we could say, we know this is bad, turn it into what's good. And it knew it learned what the different bad patterns were. And this was for just, specific languages we support, specific vulnerability classes that we find. We want to be able to fix those things and then use human supervision on top of that to make sure it worked. Now, this is a small sample set, right? This is like, 10 or 15 different vulnerability classes over 15 different languages. You can do the matrix. It's a tractable problem, right? Yeah. That humans can review. Like, there's no way to have a tractable problem even on, asking questions about, Shakespeare's works of literature, right? It's just be very difficult for humans to review that. And that's part of the problem when you have these general purpose AIs that are just trying to do everything. And this is why we're seeing a movement to maybe small language models that just do one thing well, right? Yeah. Whether it's writing code or, diagnosing cancer or treating cancer, because there's a fixed body of knowledge. There are experts, there are oncologists that can review the output. And you can imagine having an LLM that knew a lot, is highly accurate around cancer. But then you say, well, be highly accurate about, every medical problem. Yeah. Now you've made a problem really big. And then say, be highly accurate about everything that people graduate with advanced degrees about. And it becomes a challenge to reach these levels of accuracy. And the problem with code is it's either vulnerable or it's not, right? Like, if it's vulnerable, it's bad.
Yeah. It's just a really interesting product motion, because I think there's so much hype around them as like a business, like, OpenAI. But in reality, I've started to categorize it as there's these AI search companies where they're ingesting the internet and they're being better at, a research partner. And then there are like us using neural network tools or LLMs to solve very specific problems.
There's right, exactly. And the same technology being used for both. And, for search, it's great, right? Like, when I search on something, I always don't get the exact right answer, even on the first page or two, right? So so the bar is kind of low, right? Yeah. But, an LLM search, if it can be better than that, and I think they are, right? Certainly saves time. It's more concise. That's a step up. But think about replacing, if you're replacing something which is like a doctor with an LLM, it's got to meet that bar, which is much higher. We're sort of in the middle here with writing code, and I think finding out that we're writing code around the same that humans are, shouldn't be a surprise. But I did want to mention one of the sort of the unintended consequences of this is not just that we're getting, the same level of vulnerabilities per line of code when the LLM does it. The LLM does it much faster, right? And if you think about software development processes, everyone is trying to go faster and be more efficient. That's why we use open source packages. Why write the code when I can just import the code, right? Yeah. And the same thing with copying and pasting out of some reference, right? Like what, even if it's Stack Overflow, like what's the answer to this question? What's the best way to use this algorithm? Copy, paste, right? So it's all about copying and wherever you can. And the LLMs just fall right into that copy, paste, insert stuff into here. So we get this higher velocity, right? Where maybe we're writing code at 1.5x or 2x what we were before we used LLMs. But if we have the same vulnerability density, that means we have more vulnerabilities to deal with per unit of time. And this is the thing I'm trying to impress upon developers. It makes it more important that you're testing quickly and then you have a plan to remediate quickly. Because otherwise, you're writing a less and less secure piece of software over time.
At an exponential rate compared to
because we can wake up next year and it's like, okay, well now it's 5x, right? I'm writing code 5x as fast, but wait a minute, I got the same vulnerability density. So we're hoping that AI-based fixing is one good way of keeping up with this until we can solve the problem of LLMs writing secure code.
Yeah. There's always another vector, Chris.
Yeah.
Like broadly in life, it's not just the number of logos you integrate, but how many things you can integrate with them that matters, and to your point, it's not just the percentage of vulnerabilities that get into code, it's how fast they get into that code as well. Yeah.
Exactly. And the other part of it is, and this is where vibe coding becomes really scary, is now you don't have necessarily professional developers doing this. Like I know a lot of professional developers are, because they're trying to see the limits of this, including the guy who coined vibe coding. Yeah. But there's a lot of people that are, maybe they took it in college, but then, a class and they haven't done it since. Or there are even some people who've never coded before writing programs. And this is truly scary. Because like, who's going to test and fix their vulnerabilities, right? So, I don't think vibe coding is ready for prime time. Like it's good for apps that you're going to run yourself on your computer. Maybe you're writing an app to create a cool graphic or chart. I've done such a thing. Munge a lot of data, solve a problem for me, but don't put PII in there and connect it to the internet, please.
Yeah. Yeah, I played with one of those tools. I am not a professional coder anymore. They've kicked me out and made me an executive at this point. Yeah. I can no longer make a commit to our Git repo. Yeah. But I was playing with an idea, and I told it to build a login and went to go log in as a user and do the sign up. And I realized no matter what I logged in, as I logged in, it's the same user I had logged out last time. And it was like, that's a very simple security issue.
It functionally worked. It let you log in.
That's right. Yeah. And without knowing that I'd been through QA processes before as an engineer myself, I wouldn't have known all the different cases that were going to get run from a security perspective against that code I wrote.
Right.
Yeah.
Right. Yeah. So that's the thing, is like, you have to define the anti-patterns that you don't want it to do. Because if you're not, then you're making an assumption that it knows what those anti-patterns are, right? And they're usually they're logic issues, right? They're logic issues. So you have to assume it. You can't assume it knows the logic anti-patterns, like, don't let anyone log in if they put in the wrong login name. If you're making a banking app, don't let anyone withdraw a negative amount of money.
Yeah. Good. Let me pressure test this a little bit. I'm curious your opinion. Maybe we see essentially tools that are either automatically scanning for vulnerabilities or developing code with less vulnerabilities. being able to handle some simple use cases, like, making sure permission is set. But there are more complex use cases and perhaps they're not ready for. And I'm trying to gauge where you think the needle is today, like something complex like XSS, like a cross-site scripting. That seems, if you go beyond that into something like a race condition or, memory failover, we're not going to be able to look for AI today at all to help guard against those particular types of issues.
Yeah, I think, well, certainly a race conditioned is, there's special tools that I know have been built just for those things. I know it seems possible, but I think you'd have to have a really good prompt to do it. And you'd have to make sure that it had enough examples in its training data set of real sort of race conditions and things like that to make sure that it learned those things. It's hard to me imagine that it's just going to sort of absorb those concepts because it isn't necessarily sort of in the comments, right?
Yeah.
Look out, put a mutex here. We're worried about a race condition, because if that's just missing. I think, and the same would probably go for, is this crypto algorithm secure? There's a lot of complexity that it would really have to understand. But I would be happy if it could deal with the simple things.
Yeah. Yeah. That is part of where I see these tools. It's like the things that seem pedantic or like someone just, in our world, clicking through a spreadsheet and looking at the thing that was delivered. That seems like an easy opportunity for a machine system to run that. And I think we're unlocking some of that energy. Yeah.
Absolutely. And that's where it can really help a senior developer who's really dealing more with hopefully architecture and design and high level algorithms, doesn't have to dot all the I's and the T's, sort of and has the LLM doing all sort of the heavy lifting. And so I mean, it's amazing productivity tools, and I just hope we can figure out how to make them better for security.
I'm going to take us just slightly off script here because I'm a little curious if you saw the MIT study around the value generated in the adoption of some of these LLMs, and certainly, their feedback that it didn't provide kind of the business value that they thought it would. I'm curious your thoughts about that. Yeah.
Yeah. So I saw the headline and some of the talk about it. I haven't read the report. It doesn't surprise me because I think that some of this stuff probably started a couple of years ago to already get to the point where it's failed. Right. Yeah. So we were just kind of learning a lot of what the capabilities are. I wonder if, let's say it went back 2 years, if we go, what's 25 to 27 going to look like? Hopefully it'll be better. But it does go to show that, just sort of jumping in on some new technology doesn't necessarily solve the problem, unless you're doing it right. And, from a cybersecurity point of view, you're just opening yourself up to so much risk. I can tell you now that we're just emerging with the techniques now for doing penetration testing and using automated tools to say, find things like prompt injection, RAG data leakage, model data leakage, and the permissioning that some of these things would have, like a customer support agent, right? You want it to be able to talk to one customer and not give the information for another customer, yeah. Right? So we're sort of in the early days of cybersecurity people saying, well, here's the framework of the problems you need to look for. And these are how to look for each one of those. Like I think the OWASP top 10 for LLMs just came out, maybe 6 months ago. So so it's still early days. So all that stuff that was built a year ago is probably hugely vulnerable. So that also scares me. But just to get back to your original point is, when technology is new, we don't always know how to use it the most effectively and best way, and it takes time. But people want to get a head start. They want to jump in. They want to rush and do it. I mean, this is more of a cybersecurity example than an effectiveness example. But we saw this with the cloud. Like how many world readable, data stores did we see happen where it's like, oh, they put their database up there and someone took the whole thing. Why? Because they left it world readable, right? Well, that seems really dumb, right? But, it's a misunderstanding of where the permissions are, what they should be, who's in charge of putting it that way, who's testing to make sure they're correct. All that stuff comes with time and sort of building those governance models around stuff. And it's just the Wild West out there right now.
Yeah. I've certainly been on some calls lately where people imagined when we say, we're AI or we have this AI tool in our platform, what it would do. And when we get into the brass tacks of what it actually does, I think they can see real value. Oh, this is an efficiency, but it's never all the hype that the engine creates.
Right. It's not quite as exciting as like, don't lay off your customer support team yet.
Hang on. Yeah. Or I think what we found too is like there's an applicability to what you mentioned to a more strategic role or a scaling the impact that a staff member can have. Yeah.
Sure. And then sometimes for productivity tools, you want to have more output, not the same output. And so I find it a little strange that you see all these companies laying off developers or, maybe freezing hiring developers makes more sense, but actually getting rid of developers doesn't. I don't think that necessarily makes sense because what if you could write twice as much software with the developers you have? Would that be a competitive advantage? Or do you want to write the same amount of software that you're doing today with half as many developers? Right? What if your competitors are doing twice as much because they can? So it's interesting to see how the productivity is actually going to change the competitive landscape and sort of human labor versus, the Gen AI labor. And maybe that's part of what's gone into these projects failing. They may have gotten productivity, but they weren't able to eliminate the jobs.
Yeah. I mean, at the end of the day,
that was the goal, was replace half my customer support team. It's a failure if you can't.
Yeah.
Even if your customer support is better.
Yeah. You find you're still competing in a marketplace. You've got to find an opportunity to use those resources to succeed at the end of the day. Yeah, you will. The business will. Chris, I am going to go listen to Soul Coughing today because I haven't heard that band in quite some time, and I'm excited to catch back up with their music a little bit. Yeah. That
first album, Ruby Vroom, we had. I think it was. I forget what the name of the song was, but I know the refrain was "Get back on the bus that'll take you down to Beelzebub." and it was just such a funny line that we would sing along with it.
That's great. I am very grateful for you spending time with me today, and of course our listeners, Chris. And I'm just very grateful for the work you've done in computer science and helping us, build great companies and great platforms with Veracode. So thanks for joining us today.
Absolutely. Thanks so much.